Yeah, good morning, ladies and gentlemen. We want to talk over new generations of conductive formulations for unsaturated polyester resins and epoxy resins. So we start with the agenda. The first three parts, I told something about BÜFA, what we are doing, and the last part is over applications and markets we are doing and already selling. Yeah, the BÜFA Group has three business units. One is a chemical distribution, like acids. Second one is cleaning and hygiene products with cleaning systems for laundries or something else. And the third one is the composite unit. BÜFA Composites has its headquarters in the north of Germany, near Bremen, and is founded on 1964 under the name of BÜFA Reaktionsharze. We have at the moment a turnover of approximately 110 million euros, and at the moment we are around about 200 people. Yeah, what we are doing, I think we are specialists for the development, production and the sale of innovative composite products for the composite industry. And these products are coatings, we call it gelcoats. These are coatings with a layer thickness of up to 1,000 microns. We have resins, adhesives, fire protection systems, color paste, and also spray equipment and machines which you need to use such materials. I think one bonus of BÜFA is that we made really special materials and tailor-made solutions for our customer. And we are on the side of the customer till the products work and everything is good. So I think we are very innovative also with the tube-all products, and we are very close to the customer. These are our main markets, the windmill industry, not the blades, but you see these houses on the windmills. This is called nacelles, really huge parts, GRP parts with our J-coats on the surface. Another big market is the marine sector. You can find these materials in the hulls and the decks of the boat. And transportation is for railway, these are fire protection systems, or for buses, for the newest fire retardant standards. And fourth one is building an infrastructure, like swimming pools or building materials. So now we come to our nano-augmented materials. BÜFA started at Q4 in 2015, the development with tube-all modified products for the composite market, and our first focus was on conductivity. In 2017, we have our own tube-all concentrates in special unsaturated polyester resins or epoxy resins. We made a new product line, it's called the BÜFA conductive line, and in this product line we have J-coats, tooling J-coat to make GRP toolings, and conductive resins for laminating process or filament widening or everything our customer needs. I think one big point is that we made a lot of tailor-made and customer-specific solutions. Sometimes customers don't have the right equipment to mix tube-all master batches really proper into the systems, and then we offer our customer with so-called intermediates. It's still liquid and it's easier for the customer to use. And the main work of the proper dispersing, it's already done, and it's easier to mix in the customer systems. Yeah, applications and markets. We identify these markets. This is pipes and tanks, ventilation systems, print rollers, control boxes, flooring coatings, and tooling J-coats. And the reason is these are products who need ESD properties or have issues with electrical discharge. And these are also applications who need a really good performance of the materials, because if it's too high viscous, it's not good for the process. Yeah, now we come into detail. One case history, and this is a selling product. We sell it nearly about 1 year with nice volumes and growing volumes. This is an isophthalic acid polyester J-coat for spray application. And we made it together with our customer who uses over the last years a carbon fiber system. And he uses really special spray equipment to spray the material. This is a J-coat with the color pebble gray. And we only need very low amounts to get a resistivity of 10 to the power 6 ohms or ohms per square. We have a really smooth, homogeneous surface with this J-coat. On the next chart, I show you some photo. You can see the difference between the old one and the new one. We have a very, very stable and repeatable resistivity of the material without any problems according to the resistivity. We have no negative influence of the weathering behavior with this material. It's on the same level like a standard material. If you use carbon blacks or graphite or carbon fiber systems, you have a loss in visibility of the material. And with the new tube-ball modified material, this is no problem. And one big point for our customer is the easy processing of the material. He can use it like a standard J-coat material with standard spray equipment, pressures and nozzles. And yeah, he's really happy with this material without any problems. A smaller version of this case you can see in the lobby live. Yeah. These are pictures why we think tube-ball has for us new possibilities for the materials. So if you use standard materials like carbon black, graphite, you have always a black material or maximum a dark gray one. And you see in the middle, this is an example of a spray J-coat. These colors with the tube-ball modification are now possible. And this is the new innovative thing. We have a lot of questions from our customer over the last year. Is it possible to do it in white or in other colors than dark gray? And yeah, now we have a material, this is possible, not every color, but really a huge range of color is possible. On the right side, this goes up to transparent, translucent J-coat systems. This is a J-coat layer of around about 500 microns and has a surface resistivity of 10 to the power 3. So it's really low for the resistivity, and it's still translucent over 4 layers, around about 4 millimeters wall thickness of this GRP part. On the left side, you see the difference between the old J-coat from our customer. It's made with carbon fibers with a magnification of 200, and the new J-coat made with tube-ball. The conductive additives are really not possible for your eyes, so you have really nice J-coat surfaces without any dark spots or something else. It looks like normal standard J-coat material. This is our newest product. We launched it at Stuttgart Composite Europe last month with a very, very good feedback. Yeah, why you need conductive tooling J-coat? Because standard unsettled polyester materials are insulators. They are non-conductive, and if you demold the GRP part from the mold, you have always electrical discharge, and the reason is a triboelectrical effect. And we made a tooling J-coat. This is the surface of the mold with a surface resistivity of 10 to the power 6 ohms, or ohms per square. This is enough to transport every electrical charge from the surface to the earthing point. And we found this is a big bonus for our customer because he has more safety for the workers and also for the environment. Over the last years, 1 up to 3 customers have some burning accidents in our production, and sometimes it could be that you have burnable liquids or from the release agent, something else near to the GRP mold, and if in the moment where you demold, you have sometimes really big lightning strikes, and if it goes to the burnable material, you have a problem. And also it's painful for the first person who contacts the mold. It's very painful. These sometimes are up to 30,000 volts in this moment of the demolding. Another benefit we found is for our customers with shorter working cycles. You have less dust on the mold. If you demold, you have the electrical charge on the surface, and every dust you have in your production site is going directly to the mold, and it's sometimes really sticky on the surface. With the new tooling J-coat, you have no charge on the surface, so you have lower dust on your surface. And this means directly better J-coat quality. If you spray the material over the dust, maybe a white color, you see gray or dark spots from the dust. We found also that our customer found that he has shorter mold preparation time because he don't have to clean the surface of the material. It's really easy. You can use air pressure, and the dust is gone, and it doesn't stick on the surface. And we found also that you need less force for the demolding of the parts because the electrical charge doesn't work against your demolding. Yeah, these are pictures from the mold on the left side. You can also see it live in the lobby. And on the right side, we make a test between the standard tooling J-coat and the new one. And these are 2 small molds. We demold the part, and after demolding, we throw a little bit dust, or in this case, it was a handful of fluor to the surface. And on the left side, with an electrostatic charge on the surface, the fluor or the dust sticks to the surface, and with the new J-coat, it's going down to the bottom. So you have really a clean mold, and you can use it quicker for the next GRP parts. Yeah, another application is the tank application. We have a low addition of conductive additives or tuballs. We found that we have a much better chemical resistance with the new material. In this tank, sometimes fuels or burnable liquids are stored, so you need a tank material which is safe in the ESD properties. We have a really nice low viscosity. This means easy application for the customer and quicker application, because the impregnation of the glass fibers is better and faster, so he can work faster. We have no reactivity drift. Sometimes with carbon black or graphite systems, the reactivity of our polyester material is lost, and the system is going slower every day. So with tubal additives, we don't have this reactivity drift. And one big point for our customer in the production is, I call it low contamination, and that means if you use carbon black graphite, it's always black, and you have a lot of dust in your production site. And with these low amounts of tubal, it's our customer like it, that they don't have to use this black powder, the normal one. Yeah, another application is a filament winding application. This is used to make huge pipes up, sometimes up to 2 meter diameter. And customers have some special products where they need color. And this is also possible with tubal additive in this formulation. These applications is mainly vinyl ester or unsaturated polyester-based resins. We found no loss of the mechanical properties using tubal. And also in this application, we have very low viscosity. This means easy to process, because this is a really quick process, and essential is that you need a fast impregnation of the roving. And also low contamination. These are really a high volume business, and normally the materials are in a storage tank, and if you use this storage tank with really black, carbon black material, you never use it for a transparent one, or you have to do a really hard and a lot of cleaning work. Yeah, last but not least, the SMC-BMC application, also with very, very low additions of tubals. Definitely more colors are possible, maybe up to a white, depends on the formulation. And also low contamination in the process, that he don't have to use carbon blacks or graphite systems. Yeah, I'm finished. Thank you for your attention.
Thank you very much, Elmar. Yeah, do you have any questions? Because I have few. You showed a lot of nice applications. Where do you see is the biggest market in the future for your applications when you use tubal?
Good question. I think from the volume, the biggest market is the pipe and tanks. These are really, really huge products. It's a project business, so it's not a continuous business. But if you have these projects, then the volumes are really, really, really big.
Thank you very much. Additionally, like the statement that the safety for the workers will increase very much. Yeah, thank you for that. So, are there any questions from the audience? Okay. Yeah.
Great presentation. Thank you for sharing. I have one question regarding your last or second last slide regarding filament winded pipes.
Yes.
Yeah. You mentioned the viscosity increase was low.
Yeah, so it's nearly not markable.
That's great. So low in comparison to what? Or alternatively, can you share what is the percentage of carbon nanotube that you are adding to get what level of conductivity?
The concentration?
Of carbon nanotube you are adding?
Oh, it's very low. I would say 0, 0.2 or 3. It depends on the values and the type of pipes you need. But you are really in low amounts.
And the viscosity increase with such addition, you are saying, is not significant?
In our experience, it's nearly not present.
Thank you.
Thank you very much. Any more questions? I'm very sure you have some. Okay.
Hello.
So, there is one question. Yeah. Okay, can you...
Matt Davis, FTI Group. For the coloured coatings, can you tell us what percentage of tubal and how much pigment you required to achieve said colour coatings?
I can tell you that it is very low,
Okay.
but I think this is too much detail.
Okay. One other question. The carbon nanotubes have been shown to improve mechanical properties. In the instance of the SMC flowing to an edge of a mold, have you found that that is affecting the 3D network?
SMC is not the easiest one. You have really long flowing way of the materials. And I think the big challenge is to get these separating from color to nanotubes, to get this working. This is the main challenge for SMC BMC, I think.
Okay, thanks.
I think here's also an additional question.
Hi, I'm Lijo from Alcoir Chemicals in Dubai. You were talking about the tooling gel coat, and in terms of safety, it has a static dissipative surface. Do you see a good customer acceptance for this product, or is it still gaining awareness?
No, we launched it at Stuttgart at the Composite Europe, and the interest was very, very big. And this was very good feedback. I think customers want this product and they need this product.
So I think that you have converted to good sales, the standard gel coats to the dissipative one.
I don't understand.
What I meant is, so have you converted the standard tooling gel coat customers with the tube-all mix? Have you converted about 50% of the customers? Just to understand how much conversion has happened.
What we are doing, we have, at the moment, we have this standard material, and the conductive is the new one. And maybe in a few years, we switched these product lines to everything conductive.
Okay, that's great. Because the reason why I'm asking is we have a resin plant in UAE, resin and gel coat production plant. So we were also looking into implementing this. So our concern was only on how much the customer is able to accept this.
I would say very good.
Yeah. Thank you.
Yep.
Okay, thank you very much. Oh, there is an additional question. By the way, for the tooling, I was present at the Composite Europe show, and the biggest crowd of people were exactly around this tooling. It was very impressive.
Good morning. I am Corvache, the CEO of Inno Materials. I have just a question. UV resistance. What is your experience when you are replacing carbon black to carbon fibers and this type of product, aging UV resistance? Do you see an advantage, or do you see maybe a negative impact, is not behaving like all kind of carbon blacks that can be used in some recipes?
So maybe we start with carbon black. You need high volumes to achieve conductivity, and also for graphite. And I think you lower the resin part in the formulation, and it's a negative influence of weathering behavior. And with these low amounts of the tube-all nanotubes, it's on the same level like a non-conductive material. So you don't see any negative influence with tube-alls that we
But
found.
the UV attack on materials, carbon black can absorb a given amount of UV. If you replace carbon black with this product, do you keep the UV resistance?
Yes.
Ah, okay.
Any more questions? Okay. So thank you very much, Mr. Greiff.